Respectable experts of a foundation Dassault System, a project is presented to your attention to learn, to analyze, and optimize in 5D space for certain benefits with abbreviated code LEAL5D in the sense of faithful, true, and correct as an interpretation of the fifth dimension. The basis of the project is the computational approach registered by Professor Nikolai Tonchev in the Patent Office of the Republic of Bulgaria for the analysis and optimization of processes and structures. Professor Tonchev is the head of the team. This slide is the continuity slide. It shows the oldest and youngest team members. I'm the PhD student Bistra Georgieva, the coordinator. Today I have the difficult task to present you the idea of the project. Good ideas are to be admired. We consider our idea a good one because in the very title we have indicated our ambition for analysis and optimization, bringing certain benefits, and all this we propose to do through digital means. In each element of the project that we intend to develop, certain benefits for users will be visible, which they will be able to implement in their derivatives of their activities. Users must be told how this can be accomplished. Nevertheless, let us try to present to the honorable jury our intentions. Our funding proposal is to develop only a few learning applications with 3D experiences and to shift the focus of the project from CAD in the construction process to CAD training in the process of management of technological processes. We are not aware of any such applications being illuminated in such a manner. The project's manager's 20 years of experience in technical decision making has created an author's specialized approach. The approach is a computationally friendly analysis and optimization tool to 5D space defined by 4 factors. The head of the project is a researcher in the field of material science, and as we know, material constants are used in every CAD system. Professor Nikolai Tonchev's idea is to create videos in which he submits his experience to the ideas of Professor Mike Ashby from the University of Cambridge, who is a well-known scientist on the choice of materials in the development of structures. We propose to appropriately transform the 5D space for the purposes of management in the plane and thus the decision maker to do analysis, optimizations, and everything he needs. Let us now see a complete identification in the management of one of our goals. This is one demonstration in 11 steps of the same research object moving from its minimum to its maximum. Our confidence to make such a funding proposal is rooted in the experience we have gained in managing 5D technological processes. We have examined the casting process of automotive aluminum wheels, rims, proposing a mold providing the best strength in 6 controlled sections. For the properties of cast aluminum rims, in the process of heat treatment, we have gained experience from a European project on Copernicus when implementing the results in an American wheel manufacturing company. We have considered the process for strengthening the coatings. For military applications such as electrolytic coatings, in ion nitriding with hardness and wear testing, in plasma layering examining adhesion and porosity. Technological experience in implementing magnesium alloys for joints from medicine was gained through a project with a university in China. Here, for the first time, completely incompatible factors such as chemical composition and processing mold were examined. And now follows an educational application of this theory which is related to the design of the exhaust structure. According to the 4 design parameters of this mover, how can a design optimization be made that exactly fulfills desired integral criterion values? We successively vary parameters of the construction, such as x1, x2, x3, and x4. With the boundary values of these 4 parameters, the combinations that will be built with the CAD system are defined, and these are actually the rational combinations through which the solution itself will be sought. It can be seen that the combinations are 15 in total. The different constructs were tested on fluid analysis, and the result is shown on the slides for options 1 to 8. For variant 9 to 15 and the optimal variant. Based on the data, a regression model was obtained with the help of which the optimization calculations are made. These are the results of the fluid analysis. Based on this already defined task and on the defined design parameters and criteria in the specified table, a model can be derived by DevMod, which can then be visualized in 5D. The idea of the input data of the fluid analysis is borrowed from the Russian colleagues, but through the DevMod approach, we have determined solutions characterized by a more optimal integral criterion. With this, we trace the technology of the reached solution using our DevMod approach. For the proposed numerical solution, a check with a fluid module of CAE system should be applied. Respectable experts of a foundation Dassaut System. This is the idea of the project, which will be implemented with the example of material science and mechanical engineering, because this is the one of the specializations of the Transport University applying for funding. The project description lists the names of the main educational videos with a short annotation to them. The monograph is a completed work of the project idea. The project manager can redesign the training videos at the suggestion of the evaluators in case the idea is accepted. The contribution of the funding organization is that by approving this project, it can create an environment for the creation of a similar software application in which part of the team can be invited as experts after the seed of knowledge has been disseminated or more precisely sown. In case of questions, do not hesitate to ask us at the attached email address ttonchev@vtu.bg. Thank you for your attention and time.